So what is going to be, I just give you a brief hint. Reflection is going to be whatever you know already. Real life example or real life connect is what the particular topic is connected to the real life. And then learn concept is the main subtopic, and then assisted practice, what I'm going to help you out, not fully solve. And then suggest this self practice you need to do by your own. Is this clear, everyone? Okay. So there is a question for you guys. What you see in this picture? Just let me know. And how it is going to be related to our particular subject, which is physical quantities. What you observe in this? Tell me. One by one. Go ahead, beta. This is going to be not, you can say one-way class. You need to tell me. Either with the help of chat, measurement tape, right? Other than this, exactly the measurement tape. Measurement tape. Okay, one more thing, clothes. Good. Other also share your views. One more thing, you don't need to shy, you don't need to frighten. I cannot able to throw my pen to you when I am angry sometimes. Okay, so it's a big advantage of your guys to get an online coaching, because in our time teacher used to do that. They throw duster, chalk, whatever they are teaching with. So it is the benefit of yours and mine too. So measurement tape and clothes. So what is related to this? I mean, why this picture is given to you? Sir, the test has been assigned. Okay, good. Tell me everyone other also.
Sir, according to measurement, according to measurement limit. So,
this is Pradhaman Dubey, right?
yes, sir.
Okay. So as you know, and as you all guys also see, and you participate in this. So one to observe, as it is a physical quantity and measurement, and the chapter name is units and measurement, right? So this is your measurement tape, or you can say measuring tape, right? And this is the cloth. So how are you going to measure the clothes? In amount of meter, like 2-meter cloth, 3-meter cloth, 5-meter, right? In not centimeter. So the length of the cloth you're going to measure. The main thing, what is length, we are going to see in the next slides. What is a length? Length is basically a physical quantity. What is a physical quantity in general? We are going to see in a minute. Now, measurement. So what is a measurement? First of all, measurement is a technique in which the properties of an object are determined by comparing them to a standard quantity. Also, measurement is the essential metric to express quantity of objects, things, and events. Is this clear? For example, if there is a thing is going to be happen, suppose you are here, and from this particular point A, you walk to this particular point B. Okay, from particular point A to particular point B, you are walking, means you are doing something. There is a physical change, physical phenomenon. So what we are going to measure? The distance between these 2 points and the length. Is this clear? The distance is basically the length. Is this clear, everyone? So what we are going to measure? The distance between 2 points. When I ask, is this clear? So please type it yes, or say yes at least. Okay. Is this clear, everyone? Everyone need to participate here. Clear, beta? Samyukta, Bhuvana, and this Mukeshwaram and Natalia. Okay. Yes, that's how. Good. So this is your real life connect. Now you one by one going to tell me what particular thing you read and what you're going to observe from the boxes. Like there are so many boxes. 1, 2, 3, 4, 5, and 6. What you guys observe from these 6 boxes, whatever the written in this. What are these? Tell me quickly. Tell me, beta. I hope and I believe everyone somewhere interested in sports, in any kind of sports. Obviously, if you are not interested in football or soccer, so some of you guys are interested in cricket, some of other sports and other physical activity. But everyone here understood what the sport is, right? Is this clear now? Okay, so tell me, you tell me, beta, Samyukta, width of score goal. What that is it? What does it mean? What it gives you?
It gives mass of a ball.
Beta, width. How width gives mass of a ball? Best answer, mass. Sometimes I'm laughing like this. Okay, it's not mass. Someone else, please. How it's mass, beta? Other than Pradyuman Dubey.
Sir, it's a length of a soccer goal. Soccer goal.
Uh, okay,
It's, um,
yeah. It's not mass. It's length. Okay. Now you tell me. Yeah, this particular is the mass of a social board. Uh, what this particular fourth box represent? You tell me, beta. Bhuvana or Bhuvana. Fourth box. What it is? I mean, it is written force which is exerted on the football by the ground before the kick. I mean, when they kick it. So tell me what it is.
Acceleration.
Beta, I'm asking fourth box. This one.
Okay, sir. Force when is accepted on the soccer ball by the ground.
So this. Anyone tell me what are all these quantities or what are all these things?
Physical quantities.
Exactly. So these all are things are physical quantities, right? Now please anyone tell me what do you guys understand by physical quantity or physical quantities? What it is? Like here you can see the image, you can relate, you can make your own definition in your mind. But I want to know what do you understand from this physical quantities. Obviously, I'm going to give you the very basic definition, what you never ever going to forget. But what do you guys understood after reading this line? Acceleration of the saucer ball by the kick, velocity of a saucer ball after the kick, width of a goal post, height of a goal post, mass of a goal ball, and this force. So as we all know, these are physical quantities. So how are you going to define a physical quantity? Tell me. Uh, yeah, you tell me, Saraveta.
Sir, which can be used to measure or identify a thing.
Hmm. More than that, measure and identify the things. Other than this, I
Sir, which
guess you
can
know
be
what is
used
a
for
physical
measurement
quantity,
of.
right?
To measure and know the value of the physical
Hmm.
quantity, sir.
I am asking what is a physical quantity. Go ahead, Pradhyuman. And
Sir, to
you can
measure.
type it Mukeshwaram because your mic is not properly with audible to me, so you can type it. Yeah, tell me what is a physical quantity.
Sir, to measure physical is like
Hmm.
length,
But
mass.
but itself it is a physical quantity. Okay, you tell me Samyukta beta. This time I'm not going to laugh. Believe me on this.
And to like,
Yeah,
derive for derivation, no?
for derivation for what?
For derivation of velocity or acceleration.
Somehow, or you all are correct, but not 100% correct. So let me check if it is given. Yes. So those quantities which can describe the laws of physics and possible to measure are called physical quantities. A physical quantity is that which can be measured. But very basic I'm going to give you, basic than this, because sometimes writing the basic
Excuse
thing
me,
is
sir.
going to be, yes,
Can I take written notes as the class is going on?
you can, but that is everything, whatever I'm writing on this page, you can get as a PDF
Okay, sir.
after ending the class. So you don't need to, invest your more time in writing. You need to invest your time in understanding the things.
Okay, sir.
It is general. Okay.
Okay, sir.
Because what happens if you are going to write now? So suppose in this particular class I have 25 or more than 30 pages this PPT. So maximum number of times, it is a general thing I'm stating right now. Maximum number of times you guys just invest your time in writing. So don't do that. Whatever I'm writing here, this converted into the PDF form, or this you get as a note. So a physical quantity is a physical property of a material or system that can be quantified by measurement. Exactly, or more basically, I'm just giving you the basic. PQ stands for physical quantity. So you can write it down. The quantity or physical quantity gives you the physical change physical change no, this sentence is not going to be sounds good to me even. Okay, this is going to be the good. To write any physical phenomena, to write any physical phenomenon, okay, to write any physical phenomenon or law of physics, or law of physics with the help of number, or you can say numeric value or unit or symbols sometimes, or symbols. Okay, we need physical quantity, and to write any physical phenomenon or law of physics with the help of numeric value or unit or symbol, we write physical quantities. Okay, and physical quantity also you can understood in this way: those quantities which can be described by the laws, describe the laws of physics and possible to measure. Obviously, whenever you may write any particular physical phenomenon, so that is going to be possible to measure. For simplest thing, if I'm going to say the length between this particular ball right now and this goal post, so what it is? A length, right? Is this clear? And you can see also that is the ball of your, and we observe the mass. What is the mass? Matter in a ball. Okay, this is height also going to give you this particular height of the goal post is describe the length in another form. In vertical form, the length is known as height. In horizontal form, the length is known as width. In simplest form, the length simple. Is this clear, everyone? Is this clear? Is this clear, beta, everyone? Okay. Obviously, PQ, or you can say physical quantity, is going to be described in two ways, or there are two types of physical quantity. Mathematically, physical quantity PQ, mathematically physical quantity is this numerical value or n into unit. So our main task for next type is to what is a unit. Is this clear? There are simplest. There are also some physical quantities which are not completely specified even by magnitude. Unit and direction also required. These physical quantities are called tensor. Example, moment of inertia. Means we require at least two things, either the direction, either units. But sometimes there is a quantity which is not going to be described with the help of this two even. So these particular kind of quantity is known as tensor. For example, strain. Strain is an also a tensor quantity. change in length upon length. You can see that that is itself a dimensionless and something quantity, but it is not defined only and only with the help of unit, magnitude or direction. Is this clear, everyone? For example, in velocity, in displacement, we require direction. This is your displacement from A to B, the shortest path. Okay, displacement. But to measure distance, which is a total path length, you can take any particular path. Clear, everyone? So this is the general difference between distance and displacement. You guys know this. I just revise you guys. Clear? So what is a physical quantity? You all understood? Should I move ahead? Clear na? Okay. So there are types of physical quantity. So we have two types in general. The physical quantity which do not depend on the other quantities are called fundamental quantities. In MKS system, the fundamental quantities are mass, length and time. In standard international SI system, the fundamental quantities are mass, length, time, temperature, illuminating power or luminous intensity, current and amount of substance. So basically there are two types of physical quantities. Okay, I can write types of PQ. Types of PQ. There are two. Okay, first one is this one, fundamental. First one is fundamental. Now what fundamental PQ is? Fundamental physical quantity is the simplest physical quantity which does not require any other quantity to describe it. Is this clear? The physical quantity which do not depend on other quantity. For example, length. Length only required length to describe it. Or you can say the distance between two things. Current. Other thing we can, because since beginning we are talking length. So that's is current. Current in any particular wire doesn't require any particular other quantity. For example, you don't need to mention time or something. Okay, tell me one thing, because you are guys going to opt JEE and NEET. Current is Q by T, right? So why it is a fundamental quantity, not derived one? Why charge is not fundamental quantity? Anyone? Because derived quantity need at least two or more than two physical quantities. So why we say that current is a this fundamental quantity? Tell me. Simple question, na? Why current?
Derived. Sir,
Ah,
sir, it is not derived from any other quantity such as length.
I can give you na this C Q by T. So Q is going to be the simplest and charge is going to be this thing, isn't it? Why current is not a fundamental quantity?
Sir, it is a fundamental quantity, right?
Which one? Charge or current?
Current.
Why? I mean, why current is a okay? Not I need to remove. Why current is a fundamental? Because
Sir,
I can.
It does not depend on any other quantities.
I can give you the formula beta in front of you. Current is Q by T. See, for example, very basic thing. Specifically, why should I ask this? Velocity or speed is distance upon time. You can say length upon time, right? So we say that then velocity is a derived quantity. Agree, everyone? Agree on my point, right? So then why we cannot say that current is a derived quantity or charge is it is a fundamental? Anyone please? Think a little bit. Because very simple, to observe charge, we need to do so many experimental technique. We need to develop so many you can say complex method, but to observe or to measure, because this is your definition, na? Those quantity which can describe the laws of physics and laws of physics and possible to measure. Can you measure charge easily? No, but you can measure current easily with the help of ammeter, right? So that is why current is treated as a fundamental quantity. Is this clear? If someone asks you in any particular oral examination or viva something after the experiment, like you do the Ohm's law experiment. Okay, good. In Ohm's law experiment, we observe V equals to IR. Then tell me why current is a fundamental quantity. Why not charge? Because current can be defined in this way, Q by T. Is this clear now? Because the definition of this particular physical quantity is those quantity which can describe the law of physics, any particular physical phenomenon, or you can say, and possible to measure. And this particular current doesn't require charge or time to measure itself. It required only ammeter. Clear? Did you get this answer or not? Answer is because we can measure current without the help of charge. With the help of ammeter. Is this clear, everyone? Okay, now one more question. What is the basic difference between mass and amount of substance? This. Tell me. This is your mass, first thing, and this is amount of substance. Why we write two separately this? Tell me please. The basic difference between mass and amount of substance. Anyone, beta, please? Because we need to switch on derived also.
Sir, mass is equal to the weight or the weight of the...
Weight is not mass. Weight is something force. Mass into gravity.
And it pulls the amount of substance is considered as volume, sir.
Okay. Volume have unit liter, if I'm not wrong. So this is not mentioned here. And even volume is a measure, derived quantity, length into length into length, not fundamental. Area also derived, area, meter into meter, length into breadth, breadth into height.
Sir, it defines the...
Anyone else, please? Very basic. Okay. See, mass is basically defined as the matter inside a body, contained by a body, confined by a body, where amount of substance is nothing but the number of atoms participating in any chemical change or chemical reaction. Is this clear? I'm going to remove this, or we write in a smaller way somewhere. So this is, it represents the number of atoms participating, participating in any chemical change. Okay, one thing you can do, it is generalized for each particular student. Whenever you take any particular class today or after this, uh, sit with a pen and paper, or you can say a copy, rough copy, or a single uh, rough register, or a, you can say, fair register for each particular subject. For physics itself, single one. For bio itself, single one. For math itself. And most of the time, I am just saying the things, or you understand in your own language, right? In your own mother tongue, in your Marathi, in your, you can say, Kannada or Tamil, whatever the language you are. So those notes going to help you out very much at the last night of the exam, or you can say before an exam or day or two. Obviously, I'm going to, I mean, you get this particular thing in a PDF form, but believe me, when you have 200 plus PDF, or you can say 100 plus PDF, so you're going to confuse. So make a notebook of your own, write few things, whatever I'm saying, like this, or whatever I'm mentioning. Okay. Sometimes I'm going to mention that is important. So take a snip, or you can say write in a shorter way, whatever the shorter way, whatever the shortest path you know this thing to write it this. Okay. So in this way, you can make your own notes, very short notes kind of thing. Obviously, everything we are going to give you, but believe me, when you read or when you revise with your own notes, so you can revise within a very shorter time. Okay. But if you are going to revise with the PDFs, with any particular thing, whatever we are providing you, so you're going to take a little bit more time. So it's one more thing, it is going to help you out, because in boards also, in 11th class also, there is a full book going to become for one particular exam, for physics, chemistry, bio, maths, and computer science also, right? So you need to make your practice in day-to-day life, other than your self study, to write the things. So you can able to write in your examination, as well as you know how to write things in point wise. Is this clear, everyone? Okay. So this is the basic thing. Okay, moving ahead. This is system of unit, and you can see why don't they measure about. Okay, let's. So there is a two type of PQ. One is, you can say, fundamental, and the second, if they don't mention, I have just mentioned here, derived one. And derived PQ, maybe they mention after this, but still, derived PQ, it is a PQ, physical quantity, which needs at least two or more than two. Okay, which needs at least two or more than two, or more than two physical quantities to describe it. Example you are going to give me. You are 7 or 8 people here, so please give me 7 or 8 different examples. Go ahead. One by one. Give me. Either write, either tell me. Do that quickly, beta. See, we have so many pages in this, and we are on still on 7th page. So do that, because after this I'm going to do a little bit. Yes, force. Other than that,
Acceleration.
Velocity.
velocity. Okay. Wait, I just hear force, and the second thing is velocity. Yeah. Third thing,
Power.
beta, just one, because others need to talk also, right?
Yes.
Uh, Power, acceleration, accelerate. Ohm's law? Ohm's law is not. Oh my goodness. Acceleration is done. So, Pradyuman, you tell me something else. I can see here 7 people, right? 7 students. So at least 7 quantities. And Mokeshwaram, you please type it down here. Other than this, force, power, velocity, acceleration. Fifth, sixth, seventh. And beta you the student join in the last. Ashrita Nahak, please turn on your camera and mic, both the things. It's okay, it happens. Our parents get excited whenever we do any particular online classes. It's quite normal.
Yes, sir.
Okay. Speed. Beta, what is the difference between velocity and speed? Tell me something else.
Sir,
You tell
speed
me.
is distance by time.
No, I'm not asking this. I'm asking any other derived quantity, derived physical quantity other than force, velocity, power, acceleration.
Area.
Okay. Other than this, just turn off your mic and yeah, Mokeshwaram, you tell me beta. Volume. Why you surrounded with only length? See, force is different, acceleration, velocity, area, volume, everything related to length. So tell me something else. Don't you hear about this? Momentum, something else. Work done. Torque. Okay, leave it. Okay. I hope and believe this is mass into acceleration. This is force per unit area, Newton per meter square. That is velocity per time. That is displacement upon time. That is length into length. That is mass into volume. Mass into velocity. And that is length into length into length. Okay. Yeah. So system of units, measurement. What it is? Measurement is defined as the action of associating numerical value with their possible physical thing. We can consider that a measurement always involves a transfer of energy or interaction between the object and the observer or observing instrument. Quantities and phenomena can be observed. For example, measurement of a height of a person. Like we are saying, someone is 156 centimeter or 5.2, 5.6. So these are basically the measurement of that particular height. Is this clear? So measurement is nothing but the observation, or you can say the numerical value related to that any particular physical quantity along with the unit is known as measurement of that particular unit. Nothing more than that. Okay, so what is a unit? Because we are since beginning talking about unit. So what it is in general? Unit, the unit of a physical quantity is the reference standard used to measure it. Nothing more than that. You can say reference standard, base of that particular unit, a base of that particular physical quantity. For the measurement of a physical quantity, a definite magnitude of quantity is taken as a standard, and the name given to this standard is called unit. Sorry. For example, let's talk about temperature. Okay. So temperature, in general, we are talking temperature for, you can say, human body. Temperature of a human body. Temperature of human body. So in general, we represent with the symbol T, and you can say 37 degrees Celsius. But we convert this degree Celsius. You can say 0 degrees Celsius is nothing but 273.15. So we neglect 0.15 Kelvin. So we added down this 273 plus 37. How much it is going to be? 0, 1, and then 1 carry, and then 310. So that is that much Kelvin. What is a Kelvin here? So as you guys see from this given example, temperature of a human body. So temperature T is 310 Kelvin. What is a Kelvin here? Kelvin here is unit, as we know, and 310 is what? 310 is the numerical value or number. So this numerical value, this number is the measurement, and this K, it is a unit, which is a standard base. Is this clear, everyone? So what is a unit in general? You guys get it or not? Is this clear, or do you have any doubt, question, query till now? So ask me, please. Clear? Everyone? No doubt? Everyone? Is this clear, beta? I remember my first online class. Ashrit, I am talking to you. In the COVID time, when I take my first online class, my siblings, my father, not my mother, she is the patient, one of the more patient, patience woman, or you can say person in my life. So she doesn't deserve me, but rest of them, like, I can visualize, I can remember those days. It happens, don't worry. You don't need to shy and you don't need to worry about it. Okay, so temperature of a human body is 37 degrees Celsius, because like whenever you guys get a fever and something, so the medical officer or this person is the doctor or the compounder of the doctor, not doctor in general, check your this particular temperature, and then he or she tells you like 110 or sometimes 105 or 9 in Fahrenheit they tell, not in degree Celsius basically, because 100 degrees Celsius is too much. Okay, so this is basically the different kinds of units or different kinds of for example, like we have for mass, gram, kilogram and tons, so we can convert and rephrase these kinds of units. So these are basically Fahrenheit, degree Celsius and Kelvin are the different units to measure the temperature, but the standard international unit is Kelvin. Is this clear, everyone? Is this clear? Good. So that is done, that is done, that is done. So units, there are the properties of unit, and these are the important, because they don't ask you as a numerical question or sometimes, but if you are lucky enough to get this particular question in your boards, or sorry, in your final examination of class 11, so you need to write these properties. So unit should be well defined. The unit should be of some suitable size. The unit should be easily reproducible. Easily reproducible means you can reproduce, for example, to convert, like for example, whenever you're going to measure, whenever you're going to buy a gold, so milligram, 1 milligram, what it is? 10 to the power minus 3 gram. Or 1 gram in general, what it is? 10 to the power minus 3 kilogram. Clear? If you are going to buy something in a huge amount, for example, rice, so 500 kilogram. What is 500 or 100 kilogram is 1 quintal, Quintal, which is 100 kilogram. So how you can write it down? 5 quintal. Simple. So that is the meaning of reproducible. The unit should not change with time. For example, if you are going to measure the mass, so that mass is going to be measured in kilogram. It is never ever going to be converted into time or something else. The unit should not change with physical condition like pressure, temperature, etc. For example, if there is a temperature is going to be, so length is going to be always and always measured in meter or centimeter or kilometer. It is not going to be converted into gram or second or ampere. Clear? In the same way, unit should be of proper size. For example, you cannot measure gold in this kilogram. You can say that, but according to the condition. For example, the gold reservoir of a Indian government is going to be somewhere in this much, 10,000 or maybe more kilogram, but gold of a household, normal household, 2 gram, 3 gram, or max to max 1 kilogram. Max, I'm saying. Okay. Household means whatever the ornaments your mummy, your any particular cousin, and you itself, because and sometimes father too, in the form of ring, chain, and so and so. So that's why I'm using household for house ornament, or you can say for house and family. That is the correct word, not household. So that is going to be max to max in 500 grams. It is more than enough. If you have 500, so you are sometimes a millionaire. Is this clear, everyone? So that is going to be dependent on the condition. So that is meaning unit should be of proper size. Moving ahead, standard unit, or you can say SI unit. The actual physical embodiment of the unit of a physical quantity is termed as a SI, or standard of that physical quantity. The standard is expressed in terms of numerical value n into the unit. So measurement of any particular physical quantity, for example, length of a road 12 meters. Here 12 is a numerical segment, which is a numerical value, numeric value, and meter is the unit. That's what I am saying since the beginning of this class. So that is not going to work. Is it clear, everyone? Clear now? Is this clear? Please turn on your cameras, everyone. Everyone means everyone. Now these are the main things. So the fundamental units. So the units defined for the fundamental quantities are called fundamental units. As we know, there are 7 fundamental units. So these are 4. On the next page we have 3 other. So what is this particular kilogram, how it is going to be defined? Just look at it. So unit of a mass. Mass is a fundamental quantity. So unit of that, it is a kilogram. What is a kilogram? 1 kilogram is defined as the mass of a platinum iridium cylinder kept in a National Bureau of Weights and Measurement in Paris. Okay, this is just a general. You never ever get that particular defined 1 kilogram what it is. So don't worry about it. Read for the information. Nothing more than that. Clear? If you are think like you need to remember this, don't do this. I don't even remember this. Clear, everyone? This is just for the information. Never ever you get this particular kind of question, define what is a 1 kilogram. Unit of length is meter. So what is a meter? Travel distance by light in vacuum. What is this? This is speed of light. So speed of light, whenever it travel in 1 second, that much, or it is equal to this much wavelength of emitting from this krypton 86. Wait, I need to describe this wavelength also. What is a wavelength? When any particular thing is moving in a wave kind of nature. What is a wave kind of nature? For example, if you throw a stone in any particular pond, suppose you throw here this is the pond, right? This in general. So in general, what you see basically, this kind of structure, this is basically the ripples. But in natural way, this is something happening, right? So this is a wave nature. Or if I just describe in this way, so when it starts from 0, this is your 0, whenever two axes are intersect each other, so that particular point is known as 0. So wavelength is nothing but in this particular kind of structure, one top to another top. The distance between two tops or bottoms is basically wavelength. So this is your wavelength. Is this clear? What is a wavelength? This wavelength means the distance between two tops or bottoms in a particular wave is known as wavelength. Clear? So when you are this particular krypton 86 is going to be oscillate. What is the meaning of oscillation? For example, this is my pen. So it is oscillate in this way. Okay. For example, bob swinging, and you guys see this particular thing of oscillating a pendulum in old movies, in big watches. So that is the oscillation. Then what are unit of time? Second. The time interval in which cesium-133 atom vibrates that much time. So that is 1 second. So now you can observe 1 second is how much large is it, isn't it? Because that much times it is going to vibrate. And I hope and I believe you know what a vibration is. Moving ahead, unit of temperature is Kelvin. It defines as the 1 by 273.16 fraction of thermodynamic temperature of triple point of water. What is a triple point of water? For general curiosity, water can be converted into ice, steam or liquid, right? Water can be seen in three phases of matter. So a particular temperature where water can be found in three of the phases: steam, or you can say liquid, or you can say ice. You can say solid, liquid, or gas. So that particular point, that particular temperature is known as triple point. In thermodynamics, in the second book, in 11th particular class, you're going to get in detail what is a triple point, what is this, either in KTG, either in thermodynamics. Is this clear? Good. Unit of current, that is ampere, amount of current which produce a force of 2 into 10 to the power minus 7 Newton on per unit length acts between two parallel wires of infinite length and negligible cross-section area placed at 1 meter distance apart in vacuum is known as ampere. Unit of luminous intensity, that is candela, small or you can say symbol is CD. Amount of intensity on 1 upon 60,000 meter square area at a freezing point of platinum 2042 Kelvin at a pressure of this much is known as amount of intensity, 1 candela. Unit of quantity, mole. It is the amount of substance which has the same number of elementary entities as in 12 gram of carbon. Okay. Wait for a while. Just read this, and if you have any particular question query, so you can ask me. Is this clear till now? You don't need to worry about the right hand side, these things, because these are just for the information. Never ever you going to see this, like define this one. So it is the amount of substance which has the same number of elementary entities as in 12 gram of carbon. What is the meaning? The number of atoms present in C12. As I already defined you, amount of substance gives you the number of atoms participating in any chemical change, in any chemical reaction. Nothing more than that. Is this clear, everyone? Clear? Should I move ahead? Just type it yes if it is, so I can go in a more profound way. So that is fundamental units. Now name of the unit, that is CVS unit, that is FPS, foot, pound, system, MKS, meter, kilogram, second, and that is SI, standard international unit. So let's quickly revise this. Length, centimeter in foot, pound system, it is foot. Okay. So that is important too. And meter in MKS system, it is meter. It is reverse. Just give me a second. So beta, it is going to be meter, and it is going to be represented M. It is going to be kilogram, kg. Okay. And do this component. Good. Sometime it's happened. Typing mistake. Okay. So length is centimeter, foot, meter, meter, then mass, gram, pounds, kilogram. Time is second in each. Kelvin is remains same. Electric current is ampere. Luminous intensity is candela. Amount of substance is mole. Okay. So these are 1, 2, 3, 4, 5, 6, 7. 7 units and the different kind of representation. Nothing more than that. It is important because sometimes what we when we are going to convert from CGS system to MKS system, CGS system to SI system, so you need to know this. Is this clear, everyone? Is this clear, beta? Good. Okay. Now this is something new because you know the type of unit, you can say fundamental and derived one, but that is supplementary fundamental units. So beta, supplementary fundamental units are those particular units which cannot be defined with the help of, you can say, more than two. For example, there are only two types of supplementary fundamental units, and these are differ uh, from the derived units, because derived units can be defined with the help of more than two this particular fundamental unit. For example, force is mass into acceleration, mass into acceleration itself a derived unit, velocity per unit time, right? In same way, momentum is mass into velocity is again a derived unit. So that is only defined with the help of fundamental. So radian, plane angle, and then solid angle, radian. So this is more important for JEE and NEET, both the things. Okay. Because if you get a question on this, so you get from this, not from any particular simple quantity. So plane angle and what a solid angle, we are going to see. Clear? Plane angle just give you the length in a rotational form, length in a circular form, where solid angle gives you the area in general. So what is a supplementary quantity and what is a plane angle? So plane angle basically plane angle. Plane angle is going to define again two lines, as you know. How are you going to define an angle? This is if this is your two lines. Okay. So this particular angular displacement is basically the angle. Or how you can define it? This is your what? Circular or angular distance, r, instead of r, or you can say length of r, length of r, which you can represent with the symbol L, and this is your radius r. So then your plane angle radian is going to be defined theta. Plane angle radian, which is theta, is arc of length divided by radius, and that is theta is L upon R. Is this clear, everyone? Here in this particular example, this is not Q. I need to make more clear. This is theta. Is this clear now? Now this theta is going to be 1 radian when this radius or arc of length is equal to the radius of a circle. Is this clear, everyone? And as you can see, this particular plane angle gives you this length in rotational, or you can say rotational length or length in circular form. So this theta, which is length of arc, gives you rotational length. Nothing more than that. Clear, everyone? Because this is something new. Other than this, you know already. You've seen this. Then moving ahead, what is a stadian? If you, obviously you guys celebrate your birthday till now. So just reverse the birthday cap or ice cream cone. So other supplementary fundamental unit or fundamental physical quantity is stadian. What is a stadian? Area cut out from the surface of a sphere, that is this, and radius is square. So this is your symbol for stadian, which is a solid angle, say radian, that can be defined as simple area of, you can say, surface divided by area, radius square. So one thing you notice in both the cases, as you can see, this is dimensionless, means length upon r, which is length by length. So it is not going to give you some dimension, but it have units. Clear? Clear na? For example, velocity is meter per second, or you can say this length upon time, which is meter per second. And dimension wise, we're going to write m0 l1 t minus 1. But it doesn't have any dimension because it is a length also, it is a length also. Meter, centimeter, centimeter. So this particular supplementary fundamental units or supplementary fundamental physical quantities are basically the dimensionless units or quantities. Is this clear? But they have units. Is this clear, everyone? Is this clear, beta? Sara, Samyukta, Bhuvana, Mokeshwaram. Good. In the same way, as you can see, if I tilted this particular thing in this way, this is your ice cream scoop or inverted birthday cap. So this is your area, this is your radius, right? So this area we talk about here, this area, and now this is your what? Solid angle, but not in this way, in this circular way, this. Okay, so this is your what? Solid angle. If this is the radius, so you can say area of surface divided by radius square. So this is again, you can see, you can observe that that is a dimensionless, but it is a unit or a supplementary fundamental unit or a supplementary fundamental physical quantity. Is this clear, everyone? So this is something new. Rest you know everything. Now properties of fundamental units. Any standard unit should have the following two properties. Invariability. What is the meaning? That is invariable. They are not going to vary. That standard unit must be invariable, thus defining distance between the tip of the middle finger and the elbows as a unit of length is not variable. For example, if you are going to measure any particular length, so it is not going to vary. It is going to be meter in weight. Availability. The standard unit should be easily made available for comparing other quantities. For example, if you are going to measure the length, so it is going to be measured only in meter. If you are going to measure this particular mass, so that it is going to observe in, it is going to measure in kilogram. Same while the duration between two physical phenomenon, this is time or charge per unit time, which is current. Is this clear? Hotness and coldness of a body, that is temperature, Kelvin. So they are not interchangeable. They are available and they are not going to compare with other physical quantities. Clear? Good. So I stop here for a minute because I think you need a break and I need break too. So after this we are going to restart. There is a 5-minute break. In coming days maybe your timing is going to be 150 minutes. Today it is a 120 minute of your class. So let's take a 5 minutes break, not more than that. Go drink water, go for a washroom also if you want to. After just 5 minutes we are going to meet and then we are going to start from this. Is this clear, everyone? Meanwhile, if you want to hear, just be and just read this, and then after 5 minutes we're going to start. There is a 5 minutes break, not more than that, because I need to drink water. Hello, hello, hello. Am I audible? Am I visible? Hello, hello. Hello, hello, everyone. Am I audible? Am I visible too? Beta? Just please let me know so we can start again. So much things. Okay. Okay. So that is standard international prefix. Prefix is, you can say, exa e to the power. I mean, that is the power of 10. For example, if you needed to write mega, or you can say mega kilogram. Not mega kilogram, sound good. Megameter, megasecond, something. Okay. Suppose you need to write MB. MB is going to be perfect example. Megabyte. Okay. And then we have a GB also, like 10 to the power 6 bytes. Because right now we are use so much data, na? So 1 MB stands for 10 to the power 6. 1 GB data is going to be, okay, wait a minute, 10 to the power 9 bytes. KB is kilobyte and so and so. So these are the kind of perfects: tera, giga, mega, kilo, heto, deca, deci, centi. And then in the next page, the smaller one: milli, micro, nano, pico, femto, atto. Is this clear? So these are basically the large, or I mean, to represent your quantity in larger way or in a smaller way. You can use these prefixes, not more than that. I mean, nothing they are going to use as a more. For example, terabyte, or you can say, yeah, in some okay, for bigger distances we're going to convert this thing in a light year. Light year is something we okay, what is a light year in general? If I just say that, so light year, because bigger distances, for example, the distance between two stars is going to be we measure in a light year. Light year is nothing, distance traveled by light in an year, and that is going to be very, very much, believe me on this. Distance traveled by light in an year. Okay, in an year. We have something astronomical unit also, AU, AMU, atomic mass unit also. So these are some different kinds of unit for particular kind of physical quantity. For example, light year, distance traveled by light in an year, and it is going to represent okay, first of all, what is a light year? Ly v into 10 to the power 8 meter per second, that much is the speed of light, right? Into, in an year, how much seconds we have? 365 into 24 into 60 into 60, right? For example, 365 days, 24 hours, 60 minutes, 60 seconds. So it is going to give you a very high amount of, you can say, if you just counted down the number of tens, so that is 1, 2, 3, 4, 5 and 8, somewhere in the range of this beta, which is 10 to the power 5. So sometimes we represent our unit in some other ways, for example, for different kind of circumstance, for different kind of requirement. What we require light year, it is used to represent distance, distance between two planets, planet. Okay. For example, the distance between Earth and Mars, Earth and Moon, Jupiter and so and so. Sir, this is electricity problem in my area, so that's why my online session is disconnecting continuously, because I am okay, beta, okay, it's okay. I can understand that, because you are living in Mumbai, so I can feel this. Okay, what is the joke all about? In Mumbai, this is the monsoon season, and in monsoon season there is so much rain, continuously for 3 to 4 months. Okay, so who the people not living in Mumbai, they don't understand that. So that is the a kind of joke, or that is the thing here. So this is the bigger units. Okay, for example, exa 10 to the power 8, 15, 12, 9, 6, 3. Most of the time you are going to use till here. 3. Hectodeca, you never ever going to use. Deci, never. Centimeter, 1 centimeter, it is going to be 10 to the power minus 2 meter. Moving, millimeter, 1 mm, that is going to use a lot, that is 10 to the power minus 3 meter. Okay, it is going to be used for any particular thing. Like milli, you can use milli in front of anything. 1 millisecond. So that is 10 to the power minus 3 seconds. Clear? 1 milligram, or you can say 1 gram is 1 millikilogram, you can understand. That is 10 to the power minus 3 kilogram. So you can say 1 milli, but you don't hear this particular word ever. Kilogram, 1 millikilogram. I just produce it right now. 1 gram. Clear? So you can use this prefixes in front of any particular other physical quantities in any particular kind of quantities. Micro you maximum number of times going to use in charge in next class. Current, micrometer, microcharge. Capacity, which is a capacitance, so and so. Nanometer is basically the distance for an atom. For example, you hear this thing. Okay, this is your yeah, clear. The middle part is the nucleus, right? And here these electrons are revolving like this. So this is an atom, representation of an atom. So atomic size is somewhere angstrom, that is 10 to the power minus 10 meter, or you can say radius of an atom. Where you going to see that? That's why I am writing radius of an atom is nothing but 10 nanometer. 10 nanometer. Yeah. This is clear? Okay. 10 nanometer. It is going to be larger or it is going to be smaller? 0.1 nanometer. You guys are not focusing here with okay, that is correct now. Clear na? 10 nanometer comes 10 to the power minus 8 meter. But 0.1 nanometer comes 10 to the power minus 10 meter, which is angstrom. You can understand in a same way pico, femto. Femtometer is the distance between two nucleons, or sorry, distance between two neutrons and protons, where the nuclear force is going to be applied. If nuclear force is going to be applied only and only in this range, not more than that. Whenever we're going to discuss about nuclear forces, we are going to discuss in this range. What is the meaning of this? Okay, what is the meaning of milli or this particular micro thing? Anyone please tell me. What do you guys understand for this? 1 micrometer. Tell me. What is the meaning of this? And what is the range you can observe, you can think that is going to be related to this? Very simple question I'm asking. 1 micrometer, what it is? You tell me, beta, Samyukta. Speak up. Yeah.
Strange one.
If you don't know, so then why don't you ask? This is related to each and every one question. I'm not asking right now only to Samyukta. If you don't know this, what is the meaning of this? Why don't you ask till now? See, I can teach the remaining thing in the next class also. It's my job. But if you don't understand, please ask me. I tell you this thing in the beginning of this lecture. You don't need to sigh. You don't need to frighten. You don't need to worry. Because maximum number of times you students think this is very basic. What if I am asking? So teacher itself and other students going to think that is the very lame question. Not a single question is a very lame or basic question or very, you can say, easy question. Believe me on this. Because if you don't know this, so believe me, most of the people don't know that also. Okay, tell me anyone else. Bhuvana, you tell me what is the meaning of this? Micrometer. What is this? Micro. Are you there? What is the meaning of micrometer?
Small, which
What
is used
what
to
does it?
measure the radius of the atom.
Sorry, I'm asking micrometer, not angstrom. What it is? This one. And where you guys going to observe this? Okay, I give you a hint. You observe in your body. Now at least tell me.
Small atoms.
Atoms you observe in your body.
No, sir. We use them to measure the atom. Micrometers we use.
Seriously, I give you this thing, na beta. Atom measured in this range. Radius of an atom. This is also radius of an atom. Then how you can observe a radius of an atom in this micro range? Who tell you this? If I give you the hint to think in a positive way, in a quicker way, your hair thread is going to be the tip of hair is in this range. What is the meaning of this? Suppose this is the 1 meter, right? Length. Length is 1 meter. If I convert this, what is the 1 micrometer? If I divide this much length 1 million times, 5 and then 6, yeah. 1 million is 10 lakh, na? Yeah. So that is the range. Means suppose there is a 1 meter. If I divide this particular thing, if I cut this particular 1 meter length into 1 million times, that much is small. Even smaller than this nib. So that is what? Your hair point. I mean your hair thread. Hair thread even not this much small, that is going to be 100 micrometers, which is 10 to the power minus 4 meter. Because you are able to see your single hair, but you are not able to see this micrometer. Is it clear, everyone? So this is the smaller range. If I am going to see that mega, means you need to multiply this much. Clear na? If I am going to say kilometer, kilometer means 1000 meter. In the same way, mega meter means you need to multiply 10,000 times into meter. So suppose if this is a meter, obviously this is not a meter even, first of all. This is somewhere 10 centimeter or 15 centimeter. So if I am going to convert this length into 10 lakh times, not even 10,000, 10 lakh times. So that is the bigger range, megameter. If I divide this particular smaller range, consider as a meter, 10 lakh times or 1 million times. So that is what it is, micrometer, 10 to the power minus 6. Is this clear, everyone? Is this clear, beta? Samyukta, Sara, Ashrita, Bhuvana, Mukeshwaram. This is to each and everyone, not only to Samyukta or not only to Bhuvana, right?
Sir, can you explain once?
Which one, beta? Mega or micro? Okay, micro is, suppose this is your 1 meter. If I divide this 1 meter 10 lakh times, 1 million times, so then you get the very, very fine, very, very invisible kind of length, and that is your micrometer. Clear? This much even is the visible thing. So it is in the range of this much, 100 micrometer, 10 to the power minus 4 meter. Clear na? Or you can say 1 millimeter, because 1 millimeter is this much. And one real life example I can give you. Take a 15 centimeter scale. In 15 centimeter scale, this is your 1 centimeter. 1 centimeter itself is divided into 10 times. 5, 6, 7, 8, 9, 10. So this much is, this small length is 1 mm. Even this is bigger. So if I convert this into this, so that is not micrometer. This is somewhere 10 to the power minus 4 meter. This much, 100 micrometer. Now you need to divide 100 times more. That is micrometer. Clear? So if you don't understand what it is, so please ask from the next slide. Okay. So example, 1 microvolt, volt is a, you can say, voltage potential difference, that is 10 to the power minus 6. 1 nanoseconds, 10 to the power minus 9. It is 10 to the power minus 9 second. And 1 kilometer, 10 to the power 3 meter. So that is the example of prefixes, whatever I am given to you in the previous slide. Is this clear, everyone? Is this clear now? Now it is clear at least, or not? See, you can believe me on this, count me on this. You never ever going to get good grades if you are going to the learn physics. Believe me on this. Okay, this is your very first class. So I'm not going to, you can say, feel you like a little bit low in this physics class, but I am going to give you a reality check. If you are think you can learn this thing, so believe me or not, no one, because this subject is going to frighten you more and more. The more you try to learn this, the more you try to enjoy this, the more you try to understand each and every single unit, single thing, that is going to be very helpful for you. If you think you can learn the formulas and then you apply the formulas in numerical, in conceptual question, in theory even, believe me, you are not going to work. Clear? This is clear, everyone? Okay. This is for all. So keep it in mind. Okay. So this is now derived units. I already covered the derived units. So we are going to quickly revise this. The derived units are in usage for commodities where the units are obtained from a combination of fundamental units. Derived units are sometimes assigned names. For instance, the SI unit for force is kilogram meter per second square, termed as Newton. The unit of power is kilogram meter square per second cube, termed as watt. Steps to find the derived unit. Fetch the formula for the quantity whose unit is to be derived. Substitute the units for all the involved quantities. The chosen units should all belong to one system on units in their fundamental or standard form. Simplify for their derived unit of the quantity to complete its final unit. Simply, whenever we have a derived physical quantity, to write the derived physical quantity, we need to write the derived physical units, which are known as derived units. And I already told you guys, simply just example, I mean taking an example for the force as it is given here. So with a force F can be represented with the fundamental unit mass into acceleration. Acceleration itself a derived unit. So it is kilogram meter per second square. And when the force is applied on a 1 kilogram body with 1 meter per second, 1 unit acceleration, which is 1 meter per second square, so that is known as Newton. Okay. 1 Newton is 1 kilogram into 1 meter per second square. Is this clear, everyone? In the same way, power is work done upon time taken. Work done is force into displacement. So what the unit here we have, power. Work done upon time taken. Work done is force into displacement upon time taken. So force into displacement is kilogram into meter upon second square into meter. This is your work done into divided by second or time. So that is kilogram meter square upon second cube. Okay, and that is when everything is going to be 1. So 1 watt is nothing, that is 1 kilogram into 1 meter per second square into 1 meter into divided by 1 second. Means you can say when work done is 1 Newton meter and it takes 1 second, I mean to do that particular power is known as 1 watt. Is this clear, everyone? Is this clear? Okay, moving ahead. Derived units, unit of speed. You can see that very easily. Speed or velocity, distance or displacement upon time. So unit of speed is meter per second. Unit of acceleration by formula acceleration we have v by t. Unit of acceleration meter per second upon second, meter per second square. Unit of force, mass into acceleration. Unit of force, kilogram into mass per mass divide what I am saying, mass into acceleration, which is kilogram meter per second square, that is Newton. Clear, everyone? Just please turn on your cameras too. See, why should I say why we say that turn on your cameras? Do you think? What is the reason behind it? Tell me, anyone. See, I'm not interested to see your faces, but there is something reason behind that. See, sometimes you guys sitting like numb or dumb, both. Dumb means you are not understanding. Dumb means you think like why this particular subject, topic, subtopic is going on. So because we have experience of teaching, so we can see you, and sometimes we crack a joke like right now I'm doing. Okay. So this is why we say that just turn on your camera. So we can read your faces sometimes, not accurately, but sometimes we are accurate enough. You can say 80%, 60%, 70%, 90% according to the experience of any particular teacher or tutor. And then according to that, we switch the particular topic so you can gain the little bit interest again or interest again in that particular subtopic, topic, subject, and then focus again. Is this clear? So that is in the benefit of yours to turn on your cameras. The more you turn on, the more focus we are going to give you. For example, Sarah and Samyukta turning on their cameras since the beginning. So I am focused more on these particular two students and Mukeshwaram also. Okay. Other than you guys, what you are doing behind the camera, I don't see you guys. So initially I am saying in 2 class I am going to say, but in 3rd class I am not going to say. Believe me on this. Because I need to cover your syllabus now. Isn't it? So this is your first class. And believe me, I am a strict teacher. Sometimes I am crack a joke, but I am a little bit strict. Because I need to cover lots of things. Believe me on this. Okay? Is this clear? But if you guys cooperate with me in a good way, in a good manner, so I can crack joke on myself on too. Don't bother about it this time. Okay. So this is your derived units. Example, compute the unit of velocity. So I'm not going to do that. That is very easy. Just quickly revise this thing. Since we know velocity is a derived quantity, yes, we know that. Obtained from distance and time. Exactly, mathematical formula. That is velocity, displacement upon time. SI unit of velocity, SI unit of displacement, that is meter. SI unit of time, that is second. So thus SI unit of velocity is meter per second. In the same way, SI unit of speed is going to be meter per second. Clear? So that is nothing to worry about. Some important derived units. Micrometer, 10 to the power minus 6, that is in the power, everything. Okay. Wait a minute. An important one. These are the power of 10. Meaning of writing this. 1 micrometer, 10 to the power minus 6 meter. 1 angstrom, I already give you. 10 to the power minus 10 meter, radius of an atom. 1 FM. FM stands for Fermi. 10 to the power minus 15 meter, range of a nuclear forces. Or range between 2 neutron, proton, neutron. 1 barn. Tell me what it is. Okay. Obviously you don't know, guys. 1 barn is also represented the area in which your radioactivity is going to be observed, that is 10 to the power minus 28 meter square. that is also related to the radioactive thing or nuclear thing. Nuclear stuff or nuclear phenomena. Okay, is this clear, everyone? Clear na beta, everyone? Okay, moving ahead. System of units, CGS, FPS, we already covered this thing. MKS, SI, let me check what is the main thing. Practical units, light year, parasec, Fermi, angstrom. I already tell you light year, parasec is something, angstrom, micrometer, astronomical unit, AU, hectometer 10 to the power minus 8, pico, nano. So these are basically the practical units of length. And then some practical units of mass, area, radioactivity, then advantages, and then length. Oh my goodness. And then triangular method. Okay, this is important. This is more important than any other thing. So till now, I'm going to teach you in a little bit quicker way. Is this clear? Because we already done this thing, right? So this is system of units. There are different system of units. We already discussed this thing in a great detail. Any system of unit contains the entire set of both fundamental as well as derived units. For all kind of physical units, for all kind of physical quantity, the preferred system units are the following: CGS, centimeter, gram, second. The unit of length is centimeter. The unit of mass is gram, and the unit of time is second, according to the guidelines of this system. FPS stands for foot. The unit of length is foot. The unit of mass is pound, and the unit of time is second, according to the guidelines of the system. MKS, meter, kilogram, second. SI, the system international units, that is the SI system contains 7 fundamental units and 2 supplementary fundamental units like radian and stadian. Moving ahead, these are the practical: light year, parasec, you can say parasec 10 to the power 15 and so and so, Fermi meter, angstrom, micrometer, nanometer, nanometer, picometer. Basically, picometer is going to be the radius of your nucleus. Radius of the nucleus. Okay, and that is the large second. You can say time duration between 2 light years and so and so. Time duration to reach out a signal from the sun. Okay, so that is parasec. And okay, wait, let me check so I can give you the proper parasec. Just a minute, wait. A practical example of parsec. These are distance. So this is also how a distance of this is not like but astronomical typical unit and weight. What we are going to measure in a few minutes. This is basically the distance, as it is clearly mentioned, it is meter. So it is going to be the distance between two galaxies like Andromeda and Milky Way. There are number of galaxies. So these are the largest unit of, you can say, this particular thing of distance. Okay, parsec, unit of expressing distance to stars and galaxies used by professional astronomers, and that is going to be give you the distance between two galaxies, and that is the light year distance between two planets. Planet is lie inside a galaxy and galaxies are something else. Is this clear now, everyone? Clear? Good. Okay. Because obviously it is going to be a number of times you're going to see the length. That is AU, astronomical unit. So, okay, here where I am going to represent L, and then this one L. So these are the large units. Other than these are the smaller or very small unit. As you can see, Fermi is the range where two proton lies close each other and there is a nuclear force. Angstrom is the radius of an atom. Micrometer is, you can say, when your hair thread or a very small thread is going to be cut 100 times. Nanometer, sometimes you can say radius of atom. Also picometer, radius of nucleus. Heptometer, more smaller than astronomical unit. Uh, Simply astronomical unit is the largest unit, distance between two what planets, or yeah, but this and this going to be distance between Earth and Moon, distance between the planet and their moons. Photometer is the smallest unit. Okay, so this is small, or you can say very small. VVS, very small. This is also VVS, very small. This is small, this is small, this is mid range. These all about the length. This is a small even, this is a small even. Okay, in the same way, this is large, this is very large, this is VVS, very large. Clear, everyone? So these are the practical units of length. Other kind of length units in other kind of scenarios. Clear? Moving ahead, some important practical units. So let's quickly recover this. Mass can be solar mass, Dalton, Chandrasekhar limit. That is the 1.4 times of mass of sun. The largest mass, Dalton, is mass of a proton 1.67 into 10 to the power minus 27 kilogram. Even the smallest mass is mass of an electron, that is 9.1. Maybe somewhere given here, 9.1 into 10 to the power minus 31 kilogram. This is mass of an electron. Solar mass 2 into 10 to the power 30 kilogram. This everything is in kilogram. Okay, mass of a solar system. Pressure, Pascal, 1 Pascal is 1 Newton per meter square. 1 bar is 10 to the power 5 Newton per meter square. Area, barn, in which we see the radioactive effect. What is the radioactive effect? We are going to learn this concept in a great detail. Radioactivity, becquerel, something. Okay, one simple thing I can give you. As you can see, nuclear power plant. So what is a nuclear power plant? Some atoms are decay itself without anything, without the help, you can say without any particular external activity. So this this activity or decay itself is known as a radioactive decay. Radiation dose for cancer, Ronson, or you can say, yeah, Rosen, T silent. Rosen is basically okay, tell me how many of you are interested to see science fiction or something science related web series or movies? Just type it. Because what happens when you see some web series, a science fiction related or any particular movie, so you gain more interest towards the physics or specifically towards the science. Okay. So, okay, what happened? There is a disaster basically. In a Germany, there is a nuclear power plant blast, and the whole city is going to be die out. So what happened there? When this particular nuclear power plant blast, so there is a activity or a radioactive decay is going to be raised basically. Due to this radioactive rays, the people have cancer, and that particular dose. Sir, can you again explain this page? This page, the current page, beta. Current page or what? Bhuvana, are you there? Current page, na? Okay. I am saying these are some practical or important units. Units. Mass. Solar mass is the mass of a, you can say, solar system. Dalton is the smallest mass. Mass of a proton, MP, but we have smaller than that. I mean, these are the some practical units which are going to be important. Pressure is 1 Newton per meter because pressure is force upon area. So 1 Newton per meter square, right? And similarly, bar is 10 to the power 5 Newton per meter square, means on 1 meter square when we have 10 to the power 5 Newton. Then area is have bar. This is the smallest quantity. Okay, everything here is going to be related to radioactivity. So when you are guys going to understand radioactivity or nuclear fusion or nuclear physics basically, then you're going to understand more. Not everything, but most of the things. For example, this becquerel, this, and then time, shake. Shake is, for example, on earthquake system. Within a fraction of second, houses and buildings going to be collapsed. That is a shake. Okay. Okay. In the next class, I'm going to give you few, you can say, movies on web series. Then you're going to get more interest in whatever I'm saying right now. So advantage of SI unit system. The SI unit of measurement is preferred over the unit measurement because it is internationally accepted. It is a metric system. It is rational and coherent unit system. Easy conversion between CGS and MKS. Use decimal system which is easy to understand and apply. Moving ahead, length. Okay, so the measurement of amount of anything from one end to other referred as a length. Conventional method to measure inch, foot, cubit, yard, mile. Okay, that is not more than that. A time need to be spent on this. Is this clear now? The measurement of amount of anything from one end to other end. This is your A, this is your B. So from one end to A to another end of B, that is your length. It can be inch, foot, cubit, yard, mile, or in MKS system it is meter. Clear everyone? Good. Okay, so triangular method, that is the method to represent the triangular. Triangulation is the method to identify the location of a point by calculating the angles it from two no sides rather than the calculating distance directly. So alpha, beta, gamma, D, as you can see, simply, if you remember this thing, simply, wait. What is the meaning of this? How many of you remember the sine, cos, tan, something and so and so? In the same way, you can go for alpha, beta, gamma. If this is your theta, this is your perpendicular, this is your base, this is your hypotenuse. Okay, and you know this particular angle theta. Suppose this is theta, here is 30 degree. So you know tan 30 degree value, and which is 1 by root 3, and tan theta is P by B. So you can find the any particular length. If it is 1 is given only, suppose base is given to you. Oh, sorry, perpendicular is given to you, perpendicular is 15 meters. You need to find base of this particular triangle. So easily base B, which is P upon tan 30 degree, which is 15 upon 1 by root 3 into root 3. So that is your. Is this clear now? So you can find the length with the help of this angle also. And using this, we can go ahead for a parallax method. Parallax method is to find the large distance. On the next page, we are going to see. So what is a parallax displacement or shift in the apparent location of an item when observed from two distinct positions? View is known as parallax method. What is the meaning of this in general? As you can see, your stars, your moons going to be vary in this particular way. For example, satellites also. Clear? So this is a motion of Earth around the sun. This is your distance orbit. So with the help of this angle, with the help of this tiny angle, which is a parallax angle, we can find the distance. Is this clear? So the displacement or shift in the apparent location, because why we say that this is the apparent location, because if you are situated in any particular point or a fixed particular point on a ground or on earth, so you see that the particular moon is going to be at one single position, but it is going to be travel with you also. For example, we take a moon. So when you are traveling in night time, so you see that your moon, I mean that particular moon is traveling with you, and it is going to shift its position corresponding to the number of days. Initially it looks like this, then a little bit bigger, then little bit more bigger, and then after completing 28 days, because the cycle of a moon is 28 days, it is going to be in this way. This is the cycle of moon. Clear? This is the way, na? If you are not visualizing this, go and watch the night sky. Whatever the size, whatever the shape, whatever the position of this particular moon today, you're going to find a little bit different tomorrow, and then more tomorrow, and then more tomorrow. And in Hindi, Purnima. Maybe you hear this particular word. Purnima means full moon, when there is no moon. Okay. So these are the words in Hindi, or you can say in English too. So parallax method is used to find that particular distance when near star, or you can say that is going to be moved. For example, near star to this particular earth is, or you can say near, not star, but basically near natural satellite of the moon. Moon is the natural satellite of a particular earth. So it can be visualized very easily. So parallax method is going to find the distance measured by parallax method, and that is going to find with the help of theta. So what is the distance between any particular point, or the particular point, you can say a star or a planet or something, we're going to find with the help of parallax method. Is this clear? And it is going to find whenever the two things are in motion simultaneously. One easily thing you can understand in this way from this particular example. Suppose if we are sitting in any particular car or a bus, and another motorcycle or a biker is traveling in correspondence to you, and you need to find the distance between two. What if it is going to a little bit ahead? What if it is going to a little bit below? I mean, before your bike or car or automobile. So then in this method, the motion is going to be for both sides, in your side also, and in this biker or other car side also. So the same thing is happening here. The moon is going to be moved as well as the earth is also, because then you are able to see the day and night. And earth rotation is occurring in two types, around the sun, around the axis also. Clear na? So that is your motion of earth around the sun, and that is your distant star. So to find the displacement, the distance between these two, we use parallax method. Distance measured by parallax method with the help of angle, nothing more than that. D equals to 1 by P, where D is the distance of a star and P is the parallax angle, where parallax angle psi, or you can say P here, is D by theta. Simple. Is this clear? I know it is a little bit hard to digest, but it is the way it is. Okay. Is this clear? Just try to recollect, just try to imagine whatever I am saying right now. For example, you are traveling in any particular car, bike, bus, any moving thing, and thus another corresponding thing is moving besides you. Obviously, because you are not going into to see the motion of yours on the earth and then motion of the moon, but you can see that also. Try when you are driving a car or something, or someone is driving, and whenever you are riding on a bike or a scooter or something. Okay, so then you are visualize this thing. So this is parallax method, where x is the distance. Okay, let me see how much, and then we, okay. So that is the last page. So just be with me, and then two questions are there. So max to max 5 minutes we are going to take. I mean, I am going to take of yours. Then two things I am going to tell you what you need to do as a very, very important thing. Clear? Okay. So the first thing is parallax method. You know what it is a parallax method. Whenever there are two things corresponding in the movement, so you need to use this method, where where d is the distance of a star and p is the parallax angle. X is b by theta, where this, what is x? Where x is the distance of the object from the earth. B is the baseline or diameter of the earth. As you can see, this is B is the baseline or diameter of the earth. This is your B. Okay. This is your B. And this is X. The distance from object from the X is the distance of the object from the earth. B is the baseline or diameter and earth and sorry, diameter of the earth, and theta is the angle subtended by the object. This is the angle. So suppose you locate this star, you locate this particular star. So this is X is the distance and this is the theta. And how you can find X? This is the relation. X is b by theta, where d distance is 1 by p, which is parallax. Sir, I am leaving for the day. Yeah, why not? Go ahead. It's okay, Siddesh. Okay. So that is your parallax method. Moving ahead. Now this is your one question. Try to solve it. If a person covers 1.5 yards in one step, how much distance will he cover in 30 steps? That is very easy. You need to just multiply. I don't know why this question is given. So given, and I just solve for you because we are running out of time. The total number of steps n 30. Value of step d equals to 1.5 yards. Total distance covered by the person d equals to n into d, that is 45 yards. Is this clear? So that is nothing but a physical quantity, a physical unit you need to measure in the form of length. Clear? This is very basic, very easy question. Clear or not? Good. Great. Now find this. The moon subtends an angle of this degree, this minute. Okay, what is the scenario of this? Given theta is 1 degree 55 minutes. That is the minute, and if it is a more than that, so it is a second. At a baseline equal to the diameter of the earth, what is the distance of the moon from the earth? Radius of earth is this. So the baseline B is going to be twice of this. And that is the radius of earth is 6.4 into 10 to the power 6 meter. Okay. So let's solve this also. So the angle subtended by moon theta is 1 degree 55 minutes, which is going to be how much? Okay, 1 degree equals to 60 minutes plus 55 minutes. So that is going to be 115 minutes. Therefore 115 minutes okay, into 1 minute have that much radian. So you need to find first angle, and then the baseline for the moon diameter B is 2 into this, and then the distance of the moon from the X. X is B upon theta. Obviously you have baseline, you have theta. In this way you can find the distance from the moon from the earth is, the distance of the moon from the earth. The major thing here is this. Okay, 1 minute is 4.85 into 10 to the power minus 6 radian. What is the meaning of this? As we know, radian. What is a radian, beta? If this is your angle theta, okay, theta, for this theta, this L upon R, this is your length and this is your R. So for 1 minute, that much small radian you can cover. Clear na? 1 minute is, if this particular, if this is your going to be clock, so it is going to cover 60 seconds. 1 minute. That much small. Is this clear or not? This you need to remember. I explain in the next class. But other than this, is this clear or not? Okay. Now one more thing. Okay. I'm just doing a little bit. Please explain this. What beta? This minute thing. Okay. As we know, from this plane angle, theta is length upon arc. Length is this orientation, and assume your this particular angle in 1 minute. 1 minute is, suppose this is your clock. In this particular clock, there is a this hand minute. I mean second hand. The hand clock of a second, which is going to rotate. So if it is rotated 1 minute, what it is mean? It is going to rotate completely. So for 1 minute, what amount of a radian angle we going to cover? That is the radian angle for 1 minute. That is 1 minute, not degree even. This is clear now? Because you understood now 1 second is that much small something. 10 to the power so and so. Clear? Okay. So this is now, we know the distance between moon and earth, I mean distance for any particular moving planet or a star, b by theta. B we know baseline, which is twice of diameter. Sorry, not twice of diameter, that is twice of radius. Radius of earth, that is 1.28 into 10 to the power 7 meters. And theta we already find it out. Okay, one significant figure. So I am not going to start this. Significant figure we are going to start in the next class. One important thing I am going to tell you, there is a test assigned to you guys. Okay, click on this. There is a class assessment test. Here you can see 6 questions. If you find a difficulty in understanding any of the questions, let me know. But not today, because we already late. So introduction to significant figures. How much we remaining? Just introduction only. And yeah, rules to significant figures. So I can teach you this and then the rest of the next one.